Alright, so I'm going to start with exactly what Git is. It is a program that tracks versions of documents for you. People are usually familiar with it in terms of GitHub, which I'll get to later, but really what Git is useful for is anything where you want to see what changes over time. It doesn't have to be a kernel or an Android repository. It can be any group of documents. When you install Git, it's not like when you install most applications and it's something that you open and you interact with. It's more or less a background service that you have to interact with. There are a couple of front-end GUIs for it that I'll touch on a little bit, but the majority of it, and the part that you should really get familiar with, is the command line interface. I'm going to show it on Linux, but I know that it also works natively on Macs and can run in Windows under the right circumstances. Installing it is pretty straightforward. You can do it from the command line with apt-get. I'm going to show you how I have it set up here on this laptop that is, I just recently installed Linux Mint 12 on it, so there's not any setup or environment or anything. This script I put together is just simply putting together all of the things that you need to install in order to compile, namely kernels, but also to compile source-built ROMs. Depending on the version of Linux you're using, the most recent few, you need to do a little bit of extra stuff to get set up for building ROMs, but I'm not going to get into that part here. Realistically, all you need for Git to work is these, or really just this package right here, Git core. The other packages you'll probably want if you're planning on doing anything with Android-related code. The script will also copy repo and fastboot to user accessible location, and it'll prompt you for your password when you install. Just to save some time, I went ahead and already ran it on the computer. You can see obviously just normal install output all the way up to the end of the scroll log. I'll put this zip together for everybody if any of you want it. And I'll link it from my Dropbox so that way you can get it. But it's a much quicker way of setting up your build environment than having to go and look at CyanogenMod's wiki.
Now, Dan, what distro are you using to build on?
The laptop I have here is on Linux Mint 12, and the build computer that I'll show you later is also using that. Recently, I've also used 10.11 based Ubuntu, or a couple of other variants of that, as well as a lot of other distributions. But by and large, this will pretty much get everything that you need. Once you have that installed, like I said, it's not actually going to put an application anywhere. What this does is allow you to use Git commands in the command line. Here is obviously the contents of this tool package. Like I said, I'll give you guys the zip for it. From there, there's still a little bit more that you need to do to get set up for building or really doing anything else with code. Almost anytime you're using Git, you're going to want to have it going to some remote location. Sometimes that remote is GitHub. For me, usually that's my Git site, which is based in cgit at git.tm@gitdev.com. But there's a lot of different reason places that you might want to have it pushed to. The reason for that is then you can share with other people can collaborate on it, all going through that central repository. In order to get set up for that, you need to have what are called SSH keys set up on your computer. You might have already done this if you use SSH for a lot of other stuff already. GitHub has a very good write-up on how to do this. You can see obviously the link here at help.github.com/Linux setup Git. The first thing you want to do is check and see if you already have SSH keys set up, and it shows you how to do that. I know on this computer that I do not already have that, so I'm just going to go ahead and skip down. Oops. To the next step here at the generate. So this part is going to be a little bit different depending on what email address you want to use. I will use mine here. It asks where you want to save the key. This is the default location, which is fine, so you can just press enter. And then it asks you to enter a passphrase. And enter it again. Anytime that you try and push or pull from a location using what's called the SSH protocol for Git, you'll need to enter this password into your computer. So make sure it's something that you can remember. Once you've done that, it will create a file. Oh, that's not right. In your home directory, let me switch to viewing hidden files and folders. In a folder called .ssh right here, and it'll create two files. The one that you're concerned with is this idrsa.pub. I'll show you what this one looks like. It's a long key that obviously you're never going to remember, but you'll need to have this available to copy it into Git servers like GitHub or, in my case, cgit or any other Git serving software. To do that, I mean, it's just copy and paste. It doesn't expose your password. The password is saved just on your computer, so it uses this key to authenticate. Entering it in GitHub is pretty simple, but at this point I'm going to switch to the other computer and switch the camera on this laptop.
Derek Ross.
That's me, buddy.
Can you still hear me? Okay.
Yep.
And can you see my screen?
Yes.
For some reason it's not popping up. Whatever. Oh, there it is. So in your GitHub account, and I'm assuming that you can sort of get there and set up your account from scratch on your own. In the settings for it, when you get there with this account settings button here in the corner, there is something called SSH Keys. From there you can add new keys. It's pretty simple. You add it, you can call it whatever you want, and then you just paste the content of that idrsa.pub file into this. You can see that I already have, this is the one for this computer that I'm showing you right now that's saved there. Once you've done that, it will allow you to actually connect to the repository that you have on GitHub. So let me jump back to my dashboard. That's not my dashboard. They've changed things around on GitHub a lot, so I lost a bunch of, like, where did that button used to be? Okay, so here you can see that I have this one repository listed. It's not actually mine, but I have access to it. So when I go to that, you'll see up here, and you'll see this interface on every repository in GitHub. It'll have links right here. So because I have the ability to actually write data to this remote.
Yeah, hey Dan, actually I wasn't really paying attention. We just see your URC client running right now.
Oh.
What are you supposed to be showing us? Because yeah, we just see URC running.
Oh, it's supposed to be a browser. I think for some reason it won't show the browser while I'm sharing.
I mean, normally you can screen share a browser. I mean, we do that all the time.
Let me quit Quake. How about now?
Yeah, we can see. Yeah, we can see GitHub right now.
Ah, okay. So let me start back a few steps. Here's the account settings part for your GitHub account, and this button will be on every page. Once you go there, you'll get this interface, and here's the SSH keys section I was talking about, where you can add also the directions that I was showing you earlier on how to generate your key can be found right here at this setting up Git and SSH keys link. Once you've done that, I'll go back to my dashboard. I picked a kernel that's showing up here in my repositories. If it's in the your repository section right here, it means that you actually have the ability to write to it. These ones down here are just ones that I'm watching. So if somebody updates it, it'll pop up and I'll get to see it. So going to this repository, here's the interface I was talking about that'll be on every Git repository. And it'll have these links. For things that you're just watching, it'll usually be this link, this HTTP link. And let me show you what that would look like here just on one that I'm watching. It doesn't show me this SSH option. It only shows me the HTTP and the Git read only. So I can copy these repositories, whereas this one with the SSH, I can actually write to it. So for cloning a repository, which is really where you want to start, if it's a repository you own, again, it'll have this git at github.com format, and I can show you on my code site. It's going to be a relatively similar format. It's the same basic protocol, where here it's git at the different domain, where it's git.team@dev.com. But again, there's this HTTP link. That is the public link that anybody can use to copy the repository. So for cloning a repository, if this were the repository that you wanted to clone, simply click into this field, it'll highlight it for you, and then you can copy it with Control-C, and then come over here to a terminal window. Whenever you're cloning code, you want to just know where it is you're putting it at, so you can remember it and get back to it in the future. By default, the terminal will open just at the top level of your user.
We don't see terminal.
From there, I have a folder set up called Android, where I keep all of my Android stuff, with a subdirectory called code, where all of that is, followed by team@, where my team@ code is. And then I have things broken up by platform from there. You can sort of sort things and make your own file structure as you want, though.
We just see the GitHub web browser session. We don't see terminal.
How about now?
If you're using share screen, it only keeps the focus, so if you change windows, you have to reshare the screen. You know what I mean? So like each time you'd want to share a new window, you have to stop and reshare.
Okay. I don't know why this isn't working. It's still not showing the terminal. Alright, let's try this another way. Okay, now you can see the terminal windows.
Yes.
So let me get a website back up.
I'm using Google Chrome right now.
Probably a lot of us are, buddy. I am.
Alright, so to clone a repository or do anything with Git, the commands always start with the word Git, which kind of makes sense. To clone, after that it's clone, and then you paste, oops, the URL.
Derek, you have a cat crawling up your shoulder.
Who is that?
Derek Cross, you have a cat crawling up your shoulder.
Yeah.
Once you enter the command and press enter, obviously it's going to start cloning. I don't really, the password that it's prompting me for, because I do have write access on this, is that same sh key password that you created when you created the key. I'm going to cancel out of this though because I already have the code copied elsewhere. Let me see if I can get this working on the other computer this time. Can you see the terminal this time?
No.
Well, this is annoying. Hold on just a minute. Can you see the drop down this time? Let me actually stop and restart.
We did have a nice interception, or not interception, inception thing going here. We see like 3 of them.
Yeah, I don't know what the deal is. Let me see if I can exit out on that user and join back. Hold on just a second. I'll be right back. How are we now? Oh, and now you can't hear me.
No, we can hear you fine.
Oh, there it goes. I was getting a weird lag. Alright, let's see if we can get this to work this time. Okay, you can see this terminal now.
Yes.
Great.
You can also hear your
That is
upset
horribly
kitty.
annoying. So I already have a clone of that repository, or a particular branch of that repository that I was talking about earlier on this computer. You can see once you're done copying it, you can change directories into it. When you clone a repository, there are a couple of options. The typical command is git clone and then the URL to the repository that you want. You can add some additional flags onto that though. Repositories are broken up by branches. Depending on the repository, it kind of depends on how closely related those branches are. They don't actually have to be common in any way, shape, or form, but typically they are. So sometimes you don't necessarily just want to clone whatever the master branch is. Repositories will designate one of their branches as sort of the primary or master branch. Just git clone URL will copy that master branch and not the other one per se. What you can do is git clone the URL, and then once you've done that, select the branch that you want. You can also add a flag to the clone command. So if you add -b, then you can select any of the branches that are listed on that particular URL repository. So for example, going back to, and can you see the browser here? No, you can't. Let me see if I can share the screen too. This time you can see a browser. So you can see when you're looking at a repository on GitHub, it says here branch 2.6.35-shooter ... Pushing the dropdown will show me what all of these are. This one that's on top, the owner of the repository, which in this case is Toast, has designated as being the primary branch. But this branch is the one that is actually the most up-to-date and current that you want. So you can click on it and you can see that GitHub will stutter a little bit and then load slowly and then show you it. And this is actually going to show you the different files that are related to that branch. So when you want to clone just that branch, you would use the -b and then this name of the branch that's shown right here on GitHub. You can also add an additional modifier at the end to specify the name of the directory that it is cloned into. So if you do git clone URL, some name, it will create a folder created that name and clone all of the data into that. If you don't use that modifier, it will default to using the name of the repository, which in this case is hdc-8660-kernel. So if you want to have that in some folder named something else, you can make that happen. Once you have cloned that repository, you can change directories into it, and then there's a lot of stuff that you can do. Git branch with the -a modifier will show you every branch that is related to your local working directory.
We don't see that.
Right now this shows me that I've checked out a branch that's called Android-MSM-2.6.35-ICS.
Dan, we don't see the terminal. We just see the web browser.
Oh no, this one switched, but it stopped sharing. Sorry, I switched computers. There we go. Sorry about that.
Nope.
So git branch -a will show you all of the related branches, and this shows you not just the local branches, which in this case are the ones written at the top. The selected one will always have a star next to it, and then the name. And you can see I also have this other branch locally. And then it starts going through my remotes. So when you clone a repository, it will automatically create a remote called origin that points to wherever you cloned it from. And that will list all of the branches that are at that remote location. In this case, my origin is not actually the one I was showing on GitHub. It's my personal copy of it. So the only branch there is this one that's named right here. But I also have it connected to Toast's repo right here. And so you can see where it shows each of the different branches that are on his repo. To add a remote other than the origin, or including the origin for that matter, if you're just creating a Git repository from nothing or from just some folder that you already have, is with the git remote command. Git remote add or rm and then the name of the remote that you want, and that's anything that you want to create. We'll add or remove the remote. So for removing, if I just wanted to get rm toast, and then when I do the git branch -a again, you can see I've removed that remote. But let me pull up his GitHub again. And copy the link. So then to add that remote back, it's git remote add toast is what I'm going to call it so I can remember it. And then that same URL that I talked about earlier. Hit enter. There's no feedback or anything, but then it's done, and you can check again. And it hasn't changed anything yet. The reason for that is because I've added the remote, but I haven't actually synced or pulled the data from it. So when you're pulling data from a repository, and at the moment I'm talking about one that's not your primary hosting repository, it's this extra remote that I've added, you don't just want to pull the code with git pull. What you want to do is fetch the git data. You do that with git fetch, and then that same name that you set up before. And this is going to prompt me for my password because I'm using that git@github.com style link, which is the SSH style, so it's going to require a password. And you can see it's just kind of hanging. It's going to take a little while to do what it's supposed to do, because it has to download everything from his repository and bring it in. So pushing and pulling is another important aspect, and that's the part that I guess you guys are probably really interested in learning. So with that same repository that I'm using, let me change directories to it. If I list the files there, this is all of the kernel files, and if you go back to that GitHub page and look at it on Toast or on mine, on my Git, it'll look the same. All of the files are the same, they're synchronized the same. The part that you don't see is these hidden files. The Git data keeps track of every version of every file that's in the repository. It keeps track of what's called an SHA tag for every commit that's in the repository, and for each branch that is in it. It can also track the remotes that you have. It basically does everything. So while HTC puts out code and it's 85 megabytes for Git data, a local repository on a machine is going to be more like 500 megabytes. The reason for that is, first of all, HTC's code drops are compressed. And second of all, they don't include any of this Git data. They just give you the raw code in what's called a snapshot, so no history to it or tracking. So to pull code from what's called an upstream source. So you have a local clone, and you want to pull any changes that are on the remote that's already associated with your local. It is the git pull command. This will essentially merge your local code with whatever remote you're specifying. And so in this case, I could use git pull toast and name one of the branches there, and that will pull that entire remote branch off of Toast repository into my local code. That's a little dangerous, because a lot of his branches aren't actually related to the code that I'm working on locally. So you want to be really careful with using git pull. You only want to use it with something that you know relatively directly relates, something like pulling upstream changes. The example that I would use on my kernels would be pulling changes from Cyan and John Mod's repos. My kernels are pretty much based similarly, so almost anything that they do will be able to apply to my code pretty easily, so I'll pull it. When you do a pull, it'll go through and apply each of the commits that are on that remote that aren't also on your local source. sometimes those will conflict, and it will tell you where those conflicts are. Getting into how to fix those conflicts is a little bit more about how to code, so I'm not going to touch on that, but once you have, assuming that there are no conflicts, just git pull the remote name and the branch name will merge that remote branch entirely with your local source. Once you have made changes, you want to push them back. And you do that with git push, and again, your remote name. It might be origin, if I can spell that right. Or toast would be another one that's already synchronized with this local repository. And then you can again specify a branch name. So you can push something to a new branch name by using, in a couple of ways actually. So I guess I should put that off in terms of talking about that. But the basic, what you'll do is just going to be git push origin and the branch name that you're on. When I do that, it's going to prompt me for my password and tell me that everything is up to date because my local is up to date with my remote. Please feel free, by the way, to stop me at any point if you have any questions or want me to go into more detail about something. The real meat of Git is about tracking the changes. I'm not sure if there's a way to make, to make this full screen? Or to make your Hangout full screen, Jason? You can maximize the window. That's about all I got, though. Oh, I can make the font bigger. That should help. No, apparently I can't. Never mind. No bigger text for you. Sorry. Let me see if I can get this other window shared. Why won't it let me select certain windows? That's annoying. Let me go back to the other. Okay. So, on GitHub, if you go to the commits tab, this will show you all of the tracking that goes on through Git for pretty much the entire history of the repository. If you go far enough back on this particular branch, it will show you that it's an initial upload from HTC's source, and then there's obviously a lot of commits since then. When on GitHub you look at just one particular commit, this will go through and show you what has been added, what has been removed, what's maybe been changed. It'll give you a summary by file at the top showing you how many changes. You can follow the links to jump directly to that file. But eventually we'll stop showing changes if it's too big of a change. So if you find some particular commit like this one on GitHub that you want to commit to your repository, I actually switched that. Let me back up. When you make changes to your code locally, and that can be pretty much anything, and I'm going to switch computers yet again to show you. So I have this kernel that we're working with, and I can make some random change to a file. And let's say change this number to a 3. And exit and save. So now I can add that change. And I can do it in a couple of ways. What's considered the, I guess, most direct and proper way is with git add path to file. In this course, it's just make file. Oops. You can also do a couple of other things. Git add dash capital letter A will automatically catch every change, every new addition file, and every deletion and any renames that you've made since the last commit. It'll do that automatically. The other option is git add each of the individual files that you may have changed. And the other option is to just sort of add that into the commit. And you can do that with the next step. I've added already this file, and so now I want to commit it. And I do that with git commit, and then I want to have a message attached with the commit, something to title it. So I add the -m flag for message, and then I start the commit title. And this will be what shows up on GitHub, as when you look at that commit history, that first thing, that link that's on every one, this is what will be there. And then once you do that, apparently it's going very slowly today. It'll show you that you made one, or that in that commit, one file has changed. I made one insertion and one deletion. You're saying, wait a second, I didn't delete anything. All I did was change a 2 to a 3. The way Git works is it considers you to have deleted that entire line and replaced it with an entirely new line. So that's one insertion and one deletion to make one little character change. If you add the -a flag onto git commit, and that's in this case in lowercase, it will automatically add any modified files. It will not catch new files or deleted files or renames. So I tend to use git add dash capital A to catch all of my changes, and then git commit dash M with the commit message. It makes things a little bit more complicated in terms of being more to type, but it'll make sure that you get a more consistent commits that actually catch everything that you're doing. So once you do that git commit, you can then go ahead and git push. Git push origin branch name. You can see that it has now written that new commit to my Git repository. And I can show you that here in just a second. So you can see that now here's that some random commit that I've just pushed. And then when you go and you look at it, it'll show you that change. Cgit obviously has a little bit of a different interface than GitHub, but pretty much every Git server software is going to be set up in more or less the same way. It's going to show you what the changes were. It's going to give you the SHA tag for that commit, which in Cgit is this. In GitHub on the commit is that number. So it shows you that I've made that change. And obviously you can see that it's been pushed to that remote. Unfortunately, I didn't really want that change because it's not version 3.6.35, as nice as that would be. So at this point, I want to delete that commit. Ordinarily, that's not something you want to do after you've pushed it to a remote. Somebody else might have already pulled it since you did that deletion, and that would create problems for them. but I can pretty much count on nobody having pulled that. So I can delete it, and once you do that, in order to get the remote to actually accept that deletion, you need to add a force flag onto it. But first I need to delete that. And in order to do that, I'm going to do a rebase, but I'm going to do a very simple rebase. To do that, it's Git Rebase, and I want to do this with an interactive setting because it makes it a lot easier. And I want to start the rebase at head. Head is always the top commit. The most
You don't want to change the screen.
Oh, I'm sorry. Here we go. And then you add an additional bit to that with how many commits you want to go back. I'm going to use 2 in this case. And from there, it takes you to this menu. And this shows me the top 2 commits on the Git tracking. And if I want to delete one, I can just remove it. This also allows you to go back and reword a commit, edit a commit, including changing the actual code substance of the commit, squash it into another commit, do a fix-up, which is like squash, but not appending the second message, or execute something in the middle of there. Once you've done that, you exit, save it, it'll do the rebase. And then to force push that back to my remote, it's git push remote name, branch name, and -F to force it. And so if I jump back over here to the other computer and refresh, you can see that that commit's now gone. So I mean, that's more or less the simplest usages. Some more advanced things that I'd like to cover, though, are cherry picking and amending commits. Amending commits is the easier part of this, and you can do that pretty easily. It's with git commit --amend. And this will put you into an... Switch to green screen. Yes. Git commit --amend. And this will put you into an editing screen for the most recent commit, the top commit. And so here you can see where it says the commit message across the top, and then it has a bunch of stuff commented out. That'll tell you which files are modified, as well as just some other general information about what this screen is. So in this screen, I can change what the commit message is, and that's really about it. So if I want to add some extra stuff here, I can. If I want to delete stuff, I can. And then once I'm done, I exit, save it, and it will make any changes that I've made. So if I go back and change commit like that one that I just did, in this case I didn't actually change it, but if I had, the remote version of that commit would no longer be the same. So again, I would need to do that -F force to overwrite it. Typically, you're going to be working with stuff that's newer than what's on your remote. New changes in the code. So one of the other things that you need to do with those things that you may have changed in terms of amending past commits is amending the author tag. The author tag lets people know who exactly generated this change in code. A lot of people will just make the changes, commit them, push them. And the problem with that is that it makes it look like you're saying that you are the one that came up with all of that work. And that's not always the case. Sometimes it's easier for you to just make the code changes manually and commit them, but chances are you got that from somebody. And so it's important to add that author tag. And you want to do that the same way as amending any other previous commit. It's again with git commit --amend, but then you add another flag for author, and that's --author. And that's set up in a very particular way. It's --author equals, I guess this, what, less than sign? and then quotation mark, person's name, oh, that's not what I wanted. That's not supposed to be there. There we go. Person's name, then the bracket, person's email, and then it'll bring me back to this amend screen, and it shows me now here that it's amending the author. And it's now person's name and that email. And I'm going to exit out of that, and if I were to push that back to my remote, it would no longer list me as the author of that commit. It would list person's name and that email address. The other big thing that you're going to want to be able to do with almost any repository is cherry picking code. So when you're looking around on GitHub and you see some patch that somebody's committed that you think, wow, that'd be really great in my code. You can go through and manually make all of the changes that they list, but that's kind of tedious, and you don't really need to do that. There are a couple of easier ways that you can do that, and the upside of doing it with a cherry pick is that it will maintain the author commits automatically. So that way you don't have to go back and amend your commits after the fact. So the command for git cherry pick is just git cherry pick, and then the SHA for the commit that you're looking for. The catch to this is that this is only going to work for remotes that are already synchronized locally, ones that you've already fetched locally. If it's something that's not already synced locally, then it's not going to know that SH key because it's not in the local Git data database. So you can still sort of work around that with, and I just learned this from Solarns, or Chris, who just joined us earlier today, and that was git fetch URL SHA. So if you want to just fetch some specific commit from some specific remote, you'd use that same link for GitHub that's at that top, those HTTP or those git@github.com links, and then paste that SSHA, that commit tag that goes with it. And this will automatically apply that to your local code. Once you've done that, it'll already not only apply it locally, but commit it locally, so then you can go on and just move on to your next changes. Once you make changes, you want to commit them pretty much right away, so that way you can keep continuing on and doing the other things that you want to do. So once you've made the changes and you know that they're working, you create the commit. And you do that, again, like I said earlier, with adding the files and then git commit. Once you've committed all of the things that you want to commit locally, is then when you want to push those to your remote location. I guess I can't think of anything else that I have to cover at this point unless there's questions.
Just a few things. If you forget to add a change to a commit, you can always stage that file using git add, then you can amend the commit, so you don't have to have two different commits.
Right. I was trying to avoid getting into the more complicated things of that, or merge errors or other stuff along those lines. I really
Enough.
hate that. Any other questions?
Not from me.
No? The peanut gallery? No? You guys all ready to build kernels now? Or at least clone them?
Clone them, yeah.
GitHub has a lot of features that sort of streamlines things, which is nice. It has the automated fork button, which is kind of misleading. All it does really is just create a linked version of it within your own dashboard and user domain. The special part about it is that you have push rights to your fork. When you're using a large-scale system like GitHub, it then allows you to do upstream merge requests, where if you push something to your local version, the one that's at your username, you can then ask the person from whom you forked it to apply that to their source. Even for people not using GitHub, like myself, for example, if there's some piece of code that somebody wants to get merged in, it's pretty easy for them to just say, here's the commit, and drop me a link, and then I can add it with a cherry pick. The command to list branches was git branch, and if you want to list everything that's both local and all of your remotes, the flag is -a, and that's a lowercase a. I'm not sure if the recording that you're doing, Derek, is going to record the chat. So the question there was, how do you list the Git branches?
Okay. No, you start.
He probably hears my cat. Terrible.
Hey, Teresa, what are you laughing at? Hello.
Teresa, do you have any questions?
Yeah, when are you going to start building, Teresa?
Tomorrow.
Okay.
Perfect. Really no questions?
Well, I would say it's enough to, I mean, for me to now play around at least a little bit, and after I totally screw something up or get lost, I'll think of a few other questions then, you know?
Well, the nice thing with Git is that you can always roll back to a previous commit. And one of the things I didn't cover was, I guess, how to do that. So if there's just some particular location that you want to roll back to, so let me go back to the screen share. I hate that cat. So I'm going to find the particular commit that I want to roll back to. So I just amended the author on that previous commit. So I want to roll back to the one that was before that. And I'm looking on my Git site to find the commit tag that goes with that previous commit. So to reset to that point, I want to use git reset, and I want to add the flag --hard, because that will also forcibly change all of the local files to match the point that to which I'm resetting. And then you just add the SHA tag. You can see now this is automatically reset me to that previous commit. So this would be a good example of pulling upstream changes. And then get that back from my remote. I'm going to use git pull origin and the branch name. You can see it pulled down the additional commits. And it shows that my local has now been fast-forwarded with these particular changes that are listed. And if you paid attention earlier, you noticed those were the same changes we were talking about earlier. So if you do mess something up, you can always roll back to some previous point and get back to where you started.
Okay, well, that's good to know. It seems fairly simple to do as well.
Mm-hmm. Once you get used to Git, it's pretty simple to use and it's pretty straightforward. And it makes it a lot easier for you to keep track of what you're doing.
I mean, really, it seems like, I mean, I know, you know, GitHub's slogan is social coding, you know, but really, I mean, GitHub at least, but for Git itself, the actual application, I mean, you could just use it yourself. You wouldn't even need to use it with anybody else.
Right. I mean, Cgit, which is what I use for my Git server, is a lot simpler than GitHub in terms of the features it offers. GitHub's nice. It does a lot of things sort of for you and tries to make a lot of things easier for you, which is great. And a ton of people use it, which makes it pretty useful as well. But Git can run on pretty much any computer you want it to. And you can have a Git server be almost any computer. It doesn't have to be one that you can even have a web interface like GitHub or Cgit for. It can just be that URL that you know, but not actually some physical thing that you can like go to some website and see. Derek, you had asked earlier about Garrett and sort of how that relates to Git. So Garrett is basically Git en masse. It will it'll allow you to basically make a bunch of Git commits to several repositories and then combine those all together as one Garrett upload. So the nice thing with that is that it allows you to sort of keep things unified across a whole bunch of repositories at once. And it also gives you some other advantages, like being able to synchronize it with multiple jobs as opposed to a clone that just runs with one process. You can add processes to a repo sync. That's especially useful when you're downloading something like a full AOSP clone, because that's talking more like 7 gigabytes of data as opposed to a kernel repo that's only a few hundred megabytes.
Okay. Yeah, I see a lot of AOSP ROMs, using Garrett. So I was just curious, why they're opting into using both, or in contingency to are working together.
So Garrett uses Git to do everything that it does, and if I can, let me pull an example for you of Garrett. So this is the Evervolve Garrett, and you can see if you look at a particular Garrett upload, it's going to show you the project, and this is the Git repository on Evervolve's GitHub page, is Android_hardware_QCOM_display, and it'll show you the changes. Sometimes this project, it could be, obviously a whole bunch of commits. In this particular instance, it's just this one commit, but you can see there's previous patch sets, so they've gone through a few different commits on this. So the advantage is that basically Garrett will allow you to, in one fell swoop, upload potentially hundreds of commits to potentially hundreds of different repositories all at once.
Okay.
So it's also a little bit harder to work with. You have to really know Git. You have to know Git before you use Garrett.
Absolutely. And while I may be, I guess, hosting this, I am still learning Garrett, and Chris has, even just today, taught me things about it. So there's a lot to know and a lot more to get familiar with Garrett. For just sort of building a Android ROM, really all you need to know is just the sync command to be able to download all of the code, and then the basic make commands to go through and make it. CyanogenMod has some really good wikis on how exactly to go through and do that. Obviously, they're set up for their code, but I mean, you can substitute the URL with anybody else's code, and the principles are pretty much the same. Any questions?
I can think of.
No? Well, thank you all for joining, and I hope you've learned something.
Yeah, thank you, Dan, for your class.
No problem. I think all of you guys have me on Google Talk and Google Plus, and obviously you can find me on IRC. So if you have any Git questions, feel free to stop by and ask me. In Pound TMET, you can also usually find Chris, and he knows even more than I do about Git, and a lot more than I do about Revo and Garrett. So I'm usually willing to help if you have questions. I can't answer questions like, why doesn't this random code change compile? Because I might not be familiar with the code you're looking at. If I happen to be familiar with it, I might be able to tell you, but I don't know everything just offhand.
Why not? You know?
I have yet to integrate with Google.com. I'm sorry.
Well, I'm sure it's like I said earlier, it's a good place to get started. Starting to use Git, so I'm sure some of us will, including myself, will think of a question or two, over the next couple of days, weeks, or whatever, and we'll hit you up for a few questions. Hopefully, you can help us out.
Absolutely. And so, I mean, I'm always around, and you guys know where to find me, so anytime.
All right, well, I'm going to stop recording now, so thank you again.